100 years ago, Gustav Holst's masterpiece, The Planets, premiered at the Queen's Hall in London. It has since become a favourite on the concert platform. Holst's inspiration was more astrological than astronomical. When he composed the seven-movement suite, Holst knew little of the physical nature of the worlds he represented. But thanks to a century of discovery using space probes and rovers, these are now worlds we've photographed, worlds we've touched. And yet Holst's music is just as powerful today, reminding us of the fragility of humanity adrift in the universe.
Okay.
I've been working with the BBC Symphony Orchestra and conductor Ben Gernon, exploring the latest science. The images, I think, are very powerful. I'll show you an image in a moment, which I think is probably my favourite image in the history of space exploration. We want to discover if this new knowledge can deliver a fresh insight into the music. Tonight, at a special event at the Barbican, all seven movements will be performed. This time, set to the backdrop of the latest imagery of the planets. Holst's planets were characterised by their astrological and mythological characters. So Mars, the bringer of war; Venus, the bringer of peace; Neptune, the mystic. The aim of tonight's performance is to explore how the music changes if we listen today, with the luxury of 100 years of scientific discovery, and also if we listen in today's social and political context. You see, composers like Holst were involved in and contributed to the political and intellectual arguments of the day. Holst was on the left of politics, and he was also a spiritual man. He was interested in Eastern philosophy. He learnt Sanskrit, and his music had a strong Indian influence. Now, he was writing The Planets during the First World War and just before the First World War, a time of great social and economic and geopolitical instability. His character, his interests, and his political ideas are reflected in The Planets. Precisely how, of course, is open to interpretation. That is the point of great art. But an interpretation I find interesting is that The Planets can be seen as an intellectual journey informed by Holst's socialism and his attraction to Eastern mysticism. In fact, the director Tony Palmer, in his film on Holst, wrote that in this context, The Planets begins to make sense, not as an astrological chart a la Mystic Meg, but as a pilgrim's progress from the ferocity of industrial capitalism, represented by Mars, towards a karma of enlightenment, represented by Neptune. Now, tonight, I'm not interested in arguing for this or indeed any other particular interpretation. But what I am interested in is how the work might suggest new ideas when set in a 21st century context, alongside the images and the understanding of the solar system to which we now have access. This is a modern-day spacecraft picture of Mars. Everywhere we look, we see evidence of rivers. So Mars actually was a world which could have supported life about 3 billion years ago. Now we know that there's water on Mars, there are minerals on Mars, pretty much everything you need to support human life and a civilization. And so Mars becomes not a bringer of war, kind of a terrifying red object in the sky, but a bringer of opportunity and hope.
I think it's really interesting. There's a moment, actually, in the orchestra, if we could just have a look, please. And it's 4 bars before figure 5. And I'm wondering if we could just soften this to make this more hopeful. This fanfare that we have in the brass, instead of it being da-da-da-da-da-da-da-dee-da-da-dum, could it be da-da-da-da-da-da-da-dee? So it's ever so slightly softer. And maybe, as you were saying, Brian, offers a sort of place for hope.
Mars, as Holst would have known it, was not a well-resolved planet, if you like. The photograph behind me is a photograph taken by a telescope that was commissioned in 1917, so in fact just after Holst had written the piece. What you see is a fuzzy blob. You can see dark markings on the surface, and at the time, even reputable astronomers mistook those markings for perhaps signs of vegetation. That image of Mars was dashed when we went there with spacecraft. The first spacecraft to fly past was in 1965, the Mariner 4 spacecraft. And it sent back grainy images of the surface. President Lyndon Johnson, president at the time, reflected. He said, it just may be, that life as we know it, with its humanity, is more unique than we may have thought. If we move forward to today, a fleet of spacecraft have visited. The first thing we see is a world of geological giants. You see a canyon spanning over half the face of the planet, which is called the Mariner Valley, after the Mariner spacecraft. The Grand Canyon here on Earth would fit into one of its side channels. It's also a planet of great volcanoes. We have good evidence that there were lakes, possibly even oceans on Mars. We've landed on Mars. As I speak, there's a rover called Curiosity, which is exploring an old, dry lake bed. It's found the signatures of organic molecules. It's found signatures of minerals that only form in the presence of standing water. So we've built a picture up of Mars that tells us that it was Earth-like, perhaps 3 billion, 3.5 billion years ago, with rivers and oceans and seas. In a sense, it could have been a living world. Whether life began there, we don't know. But what's interesting is this changes our view of Mars again, because a planet like Mars that had water and still has water becomes a planet that has everything you need to build a civilization, to sustain life, to sustain human beings. So even if there weren't Martians 3.5 billion years ago, even if there aren't still Martian microbes today living subsurface, there will probably one day be Martians, because the Martians will be us. Can we listen to Holst's Mars and forget the deeply ingrained 20th century symbolism of mechanized warfare? Can we instead view Mars with optimism? Having survived the barbarism of the 20th century, our technology and our rockets are now freed to deliver perspective on our cosmic isolation, to provide a bridge to the future where humanity is no longer confined to a single world. I think the photographs of Holst speak to me about the time. So he was late 30s, 40 or so when he wrote The Planets.
That Holst didn't have so much success as a composer before he wrote this piece. I often get the impression that he was searching for something deeper and more meaningful than his current existence. The First World War was on the horizon. He wanted to sign up. He couldn't sign up because he was ill. He would have seen friends and colleagues go and fight on the front, potentially never come home.
The historical context within which this piece was written is frightening. We didn't know there was an origin to the universe. We didn't know how the sun shone. So we didn't know about nuclear physics. So all those things that we almost take for granted now were not known. That's what's interesting about this. Is music from a time when we had no idea about our place in the wider universe.
And I'm intrigued to know, so if Holst was standing in his back garden at night, what could he see in the sky?
With the naked eye, he would have been able to see Venus, of course. I mean, Venus is often, depending on where it is in its orbit, but often the brightest thing in the sky, either close to sunset or close to sunrise. It's always close to the sun. So he would have seen Venus very bright, Jupiter, Saturn, Mars, again, extremely bright. But that's pretty much it. Venus, the bringer of peace. It's a planet that's very Earth-like in many ways. It's not too much closer to the sun. It's about the same size as Earth. And this really led astronomers in Holst's time to consider it potentially Earth's twin. Just like Mars, it was considered to be a world which may harbour life. We can never see the ground from Earth. It's shrouded in clouds. And that added, I think, to this idea that Venus may be a tropical paradise. But as with Mars, we had a shock when we first started to point initially radio telescopes to Venus and then began to fly space probes past the planet. We found that Venus is a scorched world. This is a photograph from a Russian spacecraft called Venera 9, which landed in 1975. It found a world that it could barely survive. It only lasted for around an hour. It measured temperatures of 465 degrees Celsius on the surface. The atmospheric pressure is 90 times the atmospheric pressure on Earth. That means if you or I stood on Venus, we would be toasted and then squashed. And if that didn't do for us, we would be dissolved because the clouds of Venus rain down sulfuric acid. So far from being an idyllic, beautiful bringer of peace, the goddess of love, Venus is the closest world to hell you could imagine. When we started peering through the clouds using radar, and we see a surface that is covered in volcanoes, far more volcanoes than any other planet in the solar system. What's interesting, though, is that it seems that, again, like Mars, Venus would have had water on the surface, may have been a habitable world, may even have given rise to life, may have been that paradise. But something went wrong on Venus. Those volcanoes pumped carbon dioxide, sulfur dioxide, greenhouse gases into the atmosphere. The cycles of the planet ran away with themselves. A runaway greenhouse effect heated the planet up and destroyed it, certainly as a habitable world. So I think the lesson of Venus is that planets are not eternal. A world that was once heaven can become hell. Venus, bringer of peace, becomes a requiem for a failed planet, and perhaps also a reflection on how rare places like Earth might be. It is a vision of hell. And I think that's fascinating when you set it against the music.
I think that this idea that there are just small falling motifs, and there's a couple of solos in the orchestra as well. So really, as a listener, you're drawn into extremely personal and lonely sounds. And then the piece ends with just the second violins playing a very long diminuendo, suspended high note, and you are left with this sense of loss.
I'm sure Holst did not intend Venus to be listened to that way. How do you feel about that reinterpretation?
So I find this layering fascinating because, human beings aren't just 1D things that write 7 notes on a page and it forever means that it's locked in history. It's almost as if he had a weird premonition of what was to come in terms of some of the research as well, because how can it be that this music is so easily transformed? And it sort of adds to the more mystical and mysterious side to his character and what he wrote.
Mercury, the winged messenger. There are spacecraft whose job it is to observe the sun. And one of them is called the Solar Dynamics Observatory. It sort of sits there and looks for solar flares and solar storms, watching how the sun behaves. But occasionally, those spacecraft capture something quite magical. They capture what's called a transit of Mercury, a small black dot tracing its way across the face of the star. Mercury sort of zips around the sun very fast. The winged messenger is a rather nice title because it's very close to the sun, but very difficult to get to. The Mercury Messenger spacecraft, it took 7 years to get to Mercury. It had to fly around the Earth once, then go around Venus twice, and then around Mercury 3 times before it had slowed down enough to get into orbit. What it found was a world that, well, we knew it would be hot. It's close to the sun. It's about 430 degrees Celsius by day on the surface. However, because there's no atmosphere on Mercury, it drops to about minus 180 degrees Celsius at night. So it's a world of extremes. Messenger found traces of what astronomers call volatiles on the surface, things like potassium. Now, that's interesting because potassium is only expected to be found on planets that form further out in the solar system. They're called volatiles for a reason. They boil away when they're close to the sun. So we now think that Mercury formed much further away from the sun than the position where it orbits today. So again, the winged messenger seems to be rather apt. Mercury has shifted a great deal in its orbit during the history of the solar system. And in fact, our simulations suggest that it's at least possible that Mercury will shift again and fly out into the outer solar system, perhaps even be lost into interstellar space. So Mercury illustrates another important point. The solar system is not a piece of eternal clockwork crafted by the gods, but a dynamic, living, and evolving place. Jupiter is a dominant planet in the solar system in a sense. It's 2.5 times the mass of all the other planets and moons combined. And that means that it is really the only object in the solar system other than the sun that has a quite profound gravitational influence on the rest of the system. For example, the asteroid that wiped out the dinosaurs here on Earth 66 million years ago is likely, or at least it's possible, that it was deflected onto a collision course with Earth by Jupiter. Jupiter is a creator and destroyer of worlds. We have a spacecraft in orbit around Jupiter now called Juno, which is sending back the most remarkable images of the planet. It's a spacecraft that for the first time orbits the north and south pole of Jupiter. When you zoom in, you see images of clouds that look almost like Impressionist paintings. The storm that we're probably most aware of on Jupiter is the Great Red Spot, but it is shrinking. So when Galileo saw the storm system, you could have lined up 3 Earths in that spot. Gives you a sense of scale of Jupiter. Now it's shrunk. You could only fit about 2 Earths across the diameter, but it's still a big and long-lived storm. Jupiter is a fascinating world in itself, but equally fascinating is its own mini solar system. Its moons, over 70 moons. And the 4 brightest were discovered by Galileo. These moons played an extremely important role in the history of human thought because they confirmed to Galileo we are not the center of the universe. Because when you look at Jupiter through a telescope, it's obvious that those moons are in orbit around it and not around us. Those moons are worlds with their own characters. Io is the most volcanically active body in the solar system. And then a rather magical world called Europa, a moon covered in a shell of frozen water ice. But we know that beneath that shell of water ice, there is an ocean of liquid salt water. It contains more water than all the oceans of the Earth combined. And so Europa may well be a home for life. Now, we got our first pictures of the planet, and particularly the moons, from 2 iconic spacecraft, Voyager 1 and Voyager 2. These spacecraft were launched in 1977. They arrived at Jupiter in 1979. We are still in touch with them both today, 41 years after they were launched. Voyager 1 is 13.3 billion miles away from Earth in interstellar space. It's a tiny little thing. I want to show you this photograph of me standing in front of a scale model of it at JPL in California. It's a remarkable engineering achievement. On Valentine's Day 1990, as it was on its way out of the solar system, it took what I think is the most famous image, certainly of Earth in the history of space exploration, when it was 4 billion miles from home. It's called the pale blue dot image. Now, there are colored stripes crossing the image, which are lens flare. But if you look carefully, in a red stripe, you'll see a point of light, which is our planet, the Earth, the pale blue dot. Carl Sagan, who's one of my great heroes, wrote a very powerful piece of prose about this image, reflecting on what it tells us about our place in the universe. The Earth, he wrote, is a very small stage in a vast cosmic arena. Think of the rivers of blood spilled by all those generals and emperors so that in glory and in triumph they could become the momentary masters of a fraction of a dot. Think of the endless cruelties visited by the inhabitants of one corner of this dot on the scarcely distinguishable inhabitants of some other corner of the dot. How frequent their misunderstandings, how eager they are to kill one another, how fervent their hatreds, our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe are challenged by this point of pale light. This idea that Jupiter might represent humility, the beginnings of the realization that we are perhaps more fragile, smaller, and more interdependent, both with each other and the wider universe, than we often like to imagine, I find fascinating in the context of tonight's performance. Holst's Jupiter, after all, contains one of the most well-known passages in classical music, the lyrical section that became the patriotic hymn, I vow to thee my country. Patriotism, the love of country. These are important ideas. They were important to Holst. But so too is the idea that we are one civilization, living together precariously on one planet in an ever-changing and always challenging universe. If we are to avoid Sagan's endless cruelties of history, we must find a way to reconcile our affection for our countries with our responsibility to protect our home world by working together. It's my view that the exploration of space has helped deliver this perspective.
And what I think is really interesting is, in terms of all the planets and all of the movements, this is the one planet that has the most important and emotional journey. That you have the physical decay of death at the beginning, and then a serene acceptance.
That's a good point. I mean, I could show so many pictures from the Cassini spacecraft, which was in orbit around Saturn for a long time. The interesting thing about this ring system that we've learned recently is that it's extremely young. Probably only tens of millions of years old. A dynamic world that's changed radically over in a fraction, the blink of an eye in geological time.
And I think how this fits in is maybe the serene acceptance could be a sense of renewal and rebirth and things growing and things not dying.
Saturn, the bringer of old age. Saturn is, I suppose, the most iconic planet made famous by its ring system. They are an intricate system, beautifully complex, made of a very simple thing: ice, water ice sprinkled around the planet, snowflakes, if you like. A friend of mine who worked on the Cassini probe, which has taken the most spectacular images of Saturn, said that it's like, you know, when you get a magnet and sprinkle iron filings over it and you can see the magnetic field. Well, in the same way, it's like some deity has sprinkled snowflakes over Saturn so you can see the gravitational field. Its rings, they look impossibly thin, and they are impossibly thin. They're in fact only around 10 meters thick. So they would fit comfortably inside this auditorium. And they also, we found, are most likely young. What we think happened was that a moon came close to the planets, probably in collision with another moon, or perhaps a gravitational interaction with another moon, and then dissociated and broke up to form the rings. It's possible that they weren't there when the dinosaurs were on Earth. So if the dinosaurs had invented telescopes and looked up at Saturn, they may well not have seen that planet that we see today. Saturn has one of the largest moons in the solar system, Titan, which in this image you see above the ring plane. Titan is the only object in the solar system other than Earth that has liquid on its surface, but it's freezing cold, a long way from the sun, minus 180 degrees Celsius or so. So that liquid is not water. It's liquid methane, liquefied natural gas. So this moon has lakes and seas and rivers of methane. It has methane rain and methane snow, a methanological cycle in the same way that Earth has a hydrological cycle. We also think that it may have liquid water below the surface. So again, this is an interesting moon in the context of life. But there is another moon around Saturn that is equally, even perhaps more intriguing. It's a moon called Enceladus. What we see on Enceladus are fountains of ice rising up from the surface and disappearing off into space. Beautiful, but what we think is causing those fountains is even more beautiful. We're now, I would say, certain that there are lakes of liquid water below the surface of Enceladus. And on the floors of those lakes, we think there are geological systems called hydrothermal vents. Now, that is fascinating because we think that one of the prime candidates for the origin of life on Earth, 3.8 billion years ago, are hydrothermal vent systems, where you get energy in contact with rock, in contact with minerals, and that transition from geochemistry to biochemistry happened. So this moon is one of the prime candidates to look for life beyond Earth in the solar system. And when we look at images of Saturn, which are backlit by the sun, you see the sunlight illuminating the rings, there is a diffuse ring far away from Saturn known as the E-ring, which is created by the ice fountains of Enceladus. So it's a tiny moon, but with a potentially dramatic impact in terms of the creation of the rings, but also philosophically, intellectually, as a possible home for life. So Saturn, the bringer of old age, in Holst's mind, is not a world enjoying a sedate old age. It's a dynamic world, a fast-changing system, constantly rejuvenating, raging against the dying of the light. And its moons, in particular, Tiny Enceladus, are perhaps engaged in the most spectacular rejuvenation of all. That natural transformation of rock and minerals and water and heat into living matter. The transition from geochemistry to biochemistry that brings meaning to the universe. We are now entering the mysterious dark frontier of the solar system. Uranus, the magician. These worlds would have been absolutely unfamiliar to Holst, no more than points of light, because they are so far away. When we look at Uranus through our most powerful telescopes on Earth, and here you see it through the VLT, the Very Large Telescope, it's powerful. You see that it's a planet you can see some surface features. It's a blue planet with white high-altitude clouds. And also 4 moons are visible in this VLT image. The image looks odd, though, because the moons are aligned vertically. The planet appears to be tipped up on its side, and that's because it is. That's one of the most mysterious things about Uranus. It orbits the sun with its poles leading the way. Now, why? It's almost certain that Uranus must have been hit by a large planet at some point in the very distant past, 4.5 billion years ago during the formation of the solar system, which tipped it over. Also from Earth-based telescopes, you can see that Uranus has a ring system. It's nowhere near as spectacular as Saturn's rings, but there are rings nonetheless. Sunlight out there is only 1/400th of the intensity of sunlight here on Earth. Temperatures are very low. The cloud tops minus 224 degrees Celsius. But there are very powerful winds there. The winds at the equator move at 200 miles per hour, but in the opposite direction to its spin. Very strange. But as you move up through the tropics towards the poles, the winds reverse direction and blow in excess of 500 miles per hour. The moons are beautifully named, actually. They're named after Shakespearean spirits and spirits in English literature. So Umbriel, Ariel, Miranda. Now, the only spacecraft to make it this far out was Voyager 2. The photographs, because light is so dim and Voyager was traveling so fast, are quite blurry sometimes. There's a photograph of Umbriel, you don't see much detail. And Miranda, which is one of my sort of favorite moons, because it really does look like some kind of drunken deity assembled it on their day off. It's a complete mess. Bits of rigid sort of bits of rock stuck on and big canyons. And the reason, of course, is it must have been split apart by a collision many billions of years ago and then reformed. So the Uranus system is a strange system. It's a long way away from the Earth. Voyager only spent 5.5 hours in the system as it traveled through, taking these, the only photographs we have from near the planet, and then left, leaving the strange, tilted magician behind in the twilight. Neptune does sound like the soundtrack to a 1960s science fiction movie in a way, doesn't it? It sounds very Star Trek-y, actually, at the end.
Yeah, I think he's such a mini John Williams because you hear the celestes, you hear the harps, you hear the harmony that's not quite conventional, you hear the low brooding sounds. And he does create this world that we have associated with blockbuster movies. I mean, if you were to look in the score, just at the end, at the ladies' chorus, this is a facsimile of the original score. This bar is to be repeated until the sound is lost in the distance. You have this wonderful ethereal quality to the voices where you can't quite hear what exactly is going on or what they're saying, but it creates this space for you as a listener and think, actually, what is out there?
And then you end up with this thing which is, yeah, the fading away, lost in the distance, he writes, which is...
And they're sort of harmonically resolving. There's tension, there's release, there's tension, there's release. So it's almost like the heartbeat of the music is just still slowly carrying on as it sort of disappears into the universe.
Yeah. In summer 1989, Voyager 2 arrived at Neptune, the true frozen outpost of the solar system, a planet that's known as an ice giant, dwarfs the Earth, but made, just like Jupiter and Saturn, Uranus, primarily out of gas. It's still very cold, minus 220 degrees or so at the cloud tops. But Neptune produces some heat internally. And so at some point, as you dive below the clouds and the pressures increase, there is, we expect, a zone where you could find perhaps liquid water. Neptune is a world of violent winds. We saw high-altitude clouds as Voyager passed by, clouds of methane crystals, supersonic winds that blow at speeds of up to 1,200 miles per hour. It has moons, and the largest moon is a moon called Triton. And this is so far away from the sun, very little energy falls on its surface, but we saw activity. We saw geysers erupting into the air, geysers of nitrogen sprinkling dark material downwind onto its surface, processes that we don't yet fully understand, leaving streaks across the surface of the moon. But as Voyager left the Neptunian system, it took one of the most iconic images in the history of space exploration. I think actually it's my personal favorite, and I think it enhances Holst's music more than words. Crescent Neptune and a moon Triton, a world of ice, 230 degrees below zero, orbiting a blue planet of storms. These two worlds remained unseen for 4.5 billion years after their formation, until our tiny emissary from Earth passed by on its way to interstellar space. Now, I suggested at the beginning of tonight's performance that I hope new ideas would emerge from the synthesis between Holst's music and the images and scientific discoveries we've made since the first performance of the planets, precisely 100 years ago today, on the 29th of September, 1918. And for me, they have. There are billions of planets beyond our solar system orbiting around the 200 billion stars in the Milky Way galaxy and in the billions of galaxies beyond. But we've discovered that solar systems and their planets are not necessarily, or even perhaps usually, stable on the timescales necessary to allow complex life and civilizations to evolve. So we, the human race, might be extremely fortunate to exist, and therefore we may be indescribably rare and therefore precious. I mean, imagine that there are no other civilizations in our galaxy. There would then be no music amongst the stars. Holst tells us through his music that it's up to us how we navigate our problems, to choose how, or even if, we want to undertake the journey from Mars to Neptune, from war to enlightenment. His message is amplified, I think, 100-fold by an understanding of our place in the universe, an understanding of the fragility and value of humanity, living as we do together on a small world accompanied by our 7 planetary companions adrift in the dark.